Welcome to your severe weather analysis for Geraldton, Thursday, November 27th, 2025. This morning's atmospheric sounding was taken at 10 a.m. local time. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Let's examine this morning's atmospheric profile for Geraldton. The Skew-T diagram shows our temperature in red climbing to 19.1 degrees Celsius at the surface, with the dew point in green at 10.7 degrees. That 8-degree spread tells us we have relatively dry air near the ground. Looking at the parcel paths, we are seeing essentially no convective available potential energy this morning. The mixed layer CAPE is 0 joules per kilogram, and surface-based CAPE is effectively 0 as well. However, we do have a strong wind shear environment, with 0 to 6 kilometer shear at 22.4 meters per second. The blue shaded area shows convective inhibition holding back any potential parcels. The lifted condensed level sits at 1,049 meters above ground, which would be favorable height if we had energy to work with. But without fuel, we are in a sub-convective environment this morning. Now let's see what happens as we move into this afternoon. The enhanced Skew-T shows multiple parcel analyses with the blue shaded area representing convective inhibition. The forecast maximum temperature is 21 degrees Celsius, just a modest 2-degree warming from current conditions. Looking at the heated parcel forecast plot, we can see the orange heated surface parcel path rising through the morning environment. Even with afternoon heating, we are still looking at essentially 0 CAPE. The blue shaded CIN remains in place, and the atmosphere stays stable. The heated parcel shows no free convection developing. This minimal temperature rise simply isn't enough to destabilize the atmosphere. We remain in a subconvective pattern through the afternoon. The hodograph reveals an interesting wind shear story despite our lack of instability. We are seeing winds backing with height through the lowest levels, shown by the purple trace curving from the surface. The 0 to 6 kilometer shear is robust at 22.4 meters per second. Storm relative helicity in the lowest 1 kilometer reaches 222 meters squared per second squared, and extends to 319 through 3 kilometers. The right mover supercell vector points toward the south-southwest, meaning if storms could develop, they would track in that direction. The left mover points north-northeast. This is excellent shear for organized convection, but remember, shear without instability is like having a race car with an empty fuel tank. The supercell composite parameter is 0.00, and significant tornado parameter is also 0.00, both reflecting the complete absence of CAPE. The atmospheric refractivity profile, or N profile, shows us the vertical stability structure. We are seeing elevated ducts indicated by the orange shaded bands between 1,500 and 2,500 meters. There's also superfraction near the surface shown in the yellow shading below 1,500 meters. These features indicate stable layers and temperature inversions in the atmosphere. The strong refractivity gradient near the surface corresponds to that temperature inversion we saw earlier. Above 4,000 meters, the profile smooths out considerably. This stable layering is another piece of evidence showing why convection cannot develop today, even with a strong shear environment. Bottom line for Geraldton today, we have excellent wind shear but absolutely no atmospheric instability. Without CAPE, thunderstorm development is not possible, regardless of how favorable the shear environment might be. This is a classic case of missing ingredients. Always consult the Bureau of Meteorology for official warnings and forecasts at bom.gov.au. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.